Good morning to everyone. This is Galya Kausi, Assistant Professor, Department of Mathematics, Vihar College of Engineering. Today we are going to see an outlook of a matrices. First, we have to know what is a matrix. Matrix is a system of n numbers which is arranged in the form of an ordered set of m rows, each consisting of an ordered set of n numbers. Is called a m cross n matrix. That is, m rows and n columns are arranged in a rectangular array. It is said to be of ordered m cross n. And the matrix is arranged in an array of numbers is denoted by capital letter A. The matrices have an order or dimension, that is the number of rows into number of columns. That is, A is having a 2 cross 3 matrices means we are say that 2 is mentioned for the number of rows and 3 is mentioned for the number of columns. Also, the matrices having the basic concept, that is capital A is equal to A11, A12, etc. up to A1n is given here. This A11, it is mentioned for, first one is mentioned for the row, second one is mentioned for the columns. That is, it is these are the elements of the matrix, which is simply or generally we can say that is Aij here. The first subscript indicates the row, the second subscript indicates the column. That is m cross n matrix, or we can say that n elements of the matrix. Also, matrix capital A, which can be written in the square bracket with their elements A, I, J, which is where I is denoting for rows and J is denoting for the columns. Also, we having many types of matrices. The type 1 is a row matrix. If a single row has been given, it is called as a row matrix. If a single column has been given, it is called as a column matrix. Mainly, we have to know that the square matrix. The square matrix means the number of rows and number of columns should be equal. That is same. The rows and columns should be same. We can say that it is a square matrix. And then zero matrix. If you are having all the elements in the matrix or zero, then we can say it is a zero matrix or null matrix. Next type, diagonal matrix. Diagonal matrix means except the diagonal, all the elements should be zero. Especially the diagonal matrix should be a square matrix. That means the diagonal only contains the values, the remaining will be the 0. So it is called as a diagonal matrix. Next, the diagonal, we see that diagonal elements are said to constitute the main diagonal or principal diagonal or simply a diagonal. The diagonals which lie on a line perpendicular to the diagonal are said to constitute the secondary diagonal. We have already seen that diagonal elements means we can say that it is a main diagonal or principal diagonal. Except the diagonal elements, the remaining we can say it as a which is perpendicular to the diagonal means we can say that as secondary diagonal. Secondary diagonal. This is the type of a matrix. And we can adapt so many operations for matrices. That one, addition, subtraction, scalar multiplication, and also matrix multiplications. These are the operations which are used for the properties of the matrices and the properties of the determinants. Next, we can go on. This problem is just for a practice they have given here. And let to know next the determinant. So now we have to know the determinant. See, if you're having a matrix, it may be the differences between the matrices and determinants is nothing but the matrix will give the solution in the matrix form itself, and the determinants given exact value of the matrix. So then the next main difference means the determinant should be a square matrix, but the matrix may be in any form, whether it may be 2 cross 3 or 3 cross 4, whatever it may be. So these are the differences between the determinants. Here we are considering the 2 cross 2 matrix. Capital A is equal to A11, A12, A21 and A22. It is a 2 cross 2 matrix is given here. Already I have told that determinant should be a square matrix. That is why they have given 2 cross 2 matrix. Determinant of A is denoted by, is just a mod of A as number and can be evaluated by. This is the way you have to evaluate it. First you have to multiply the main diagonal, and then have given operation called minus, that is subtraction, with the secondary diagonal is the value given here. This is the determinant. Next, for we've already seen for the 2 cross 2 matrix. What is an easy thing, that is evaluate the in determinants. It is example given for the determinant 1 2 3 4. First you have to do the main diagonal, second you have to do the secondary diagonal. Finally you are getting the answer minus 2. And then the next one, we have seen 2 cross 2 matrix. Now we are going to see the 3 cross 3 matrices, how we have to do this. The procedure has been given. Its determinant can be obtained by the mod of A is equal to, they have given the values. They have taken the third column as a main thing. The matrix multiplication has a lot of rules. Here they have taken the, why they have mentioned the third value means, third column means they have taken the third column and they have done the matrix multiplication here. So we are getting this value. Finally, it is equal to 0. You can use other columns also, but especially they have given the third column here. Next, inverse of a matrix. Generally, we are having an inverse matrix. First, the matrix should be a square matrix of order n. The square matrix B of an order, same order, is called the inverse of capital A. We are taking here we are taking a square matrix capital A, and its inverse is we are taking the square matrix capital B of the same order. The order should be same for the inverse also, and it is denoted by A power minus 1, that is A inverse, or B, or capital B. The necessary and sufficient condition for finding inverse is that the matrix must be a non-singular matrix. It should be non-singular. That means if you are finding out the determinants, the answer should not be 0. That is called as a non-singular matrix. That is, it is also given that its determinants is not equal to 0. Next, last one is A inverse is equal to adjoint A divided by mod A, where mod A is not equal to 0. In the denominator, that value should not be equal to 0. That is what mentioned here. This is the inverse of a matrix. Next, the remaining of types of matrices, it's a major value, that major type, that is orthogonal. A matrix capital A is called orthogonal if A into A transpose equal to A transpose into A equal to I. That means I is nothing but the identity matrix. If we are taking a matrix, and also if we are taking a matrix A transpose, we are multiply if both means, we'll get the answer as a unit matrix. That is, diagonally you have only one in the main diagonal values. And then to prove that, they've given an example also. Here, if you are taking A as this matrix, A transpose means you have to interchange the rows and columns, is called as the A transpose. After that, if you are multiplying A into A transpose, we will get the value as the unit matrix. Unit matrix means, again I'm saying that only in the main diagonal we are having one values, 1 1 1 1. The remaining all are zeros. That is called as a unit matrix. We will see the orthogonal matrix represents a rotation in fact. Next one, the properties of the determinants. If every element of a row is 0, example, every rows, if every element of a row or column is 0, here only one row is 0 means we get the value as 0 for the determinant. Easily you can find out. If they ask to find out a value for a determinant, just check out the values. If any column or any rows or all are 0 means, obviously the answer will be 0. So that is the property they have given for the determinant. Second one, mod of A transpose is equal to mod A. If you are taking A transpose determinant, the same answer will be obtained for the determinant of A also. And then determinant of AB equal to determinant of A into determinant of B. You can write like this. So when you are multiplying A into B, and then if you are taking a determinant value, or else if you are taking a determinant of A into determinant of B, we'll get the same value. That is why they are mentioned here, that is determinant of AB equal to determinant A into determinant B. Next one, properties of matrices. As like the determinant property, matrices also have some property, that is AB the whole inverse. If you're taking this value, how we have to write is which is equal to B inverse into A inverse. Next one, A transpose to the power of transpose equal to A. If you're having a matrix called A, taking transpose and also taking again a transpose, you will obtain the answer as A. And lambda A to the power of T transpose. Here lambda is nothing but it is in scalar value. When we are multiplying these two things, if you're taking transpose, the scalar will not contain the transpose. It will be the same because it is a number. The scalar lambda into A transpose. Then the third point, A plus B the whole transpose equal to will get A transpose plus B transpose. Both are equal. Next, A B the whole transpose equal to B transpose into A transpose. As similar the inverse. As like the inverse, we will have the transpose also. These are the properties of the matrices. And the most important thing, you have to know what is a skew matrix and also the symmetric matrix. And now we are first to see the symmetric matrix. If we are having a matrix capital A whose transpose is equal to the matrix. The matrix, if you are having a matrix with the right transpose, both are equal means we can say that it is a symmetric matrix. A plus A transpose must be symmetric. Why? Just a given examples, if you're taking the number of if we are taking the number of rows and columns as interchange in the transpose, we'll get the same value again means that is called symmetric matrix. A matrix such that A transpose is equal to minus A is called a skew symmetric. See, for the symmetric matrix, if you are interchanging the rows and columns, then we will have A equal to A transpose, that is called as a symmetric matrix. But for the skew symmetric matrix, we are having that A transpose equal to minus A. Only minus is included here, that is called as a skew matrix. And then the properties of a matrices. Again, we have some properties. A, B, C or conformal. Here we are taking C also, another matrix. A into B plus C equal to AB plus AC. First property. Second property, A plus B the whole C equal to AC plus BC. Then A into BC equal to AB into C. So these are the properties. And then AB is not equal to BA in general. When you are taking matrices or multiplied, A into B, but here we don't have that B into A in general, which is not equal. Sometimes it not may be equal. AB is equal to 0 not necessarily imply if A equal to 0 or B is equal to 0. The last one, AB equal to AC, not necessarily imply B equal to C. So these are the properties of matrices. The remaining properties are commutative law, associative law and distributive law. So these are the things, A plus B equal to B plus A, commutative law, and then associative law, A plus B plus C equal to A plus B plus C. This is associative law. And lambda of A plus B equal to lambda A plus lambda B, where lambda is a scalar. This is the distributive law. And the last one, a trace of a matrix. Here for trace of a matrix, you have to take only the square matrix. The square matrix and the sum of all the diagonal elements. Just add the diagonal elements is called a trace of A. It is denoted by TRA. Trace of a matrix is nothing but it should be a square matrix and only you have to add the diagonal elements, that is called as a trace of a matrix, which is the examples are given below. 3 cross 3 and 2 cross 3 matrices are given here. So, thank you.